Hi guys, on the website you find some information about how to implement a optimization technique called constant folding, and in this video I want to give you a basic idea what this optimization technique is about. Let's consider this simple assignment expression and how currently our compiler is handling this assignment expression, how it generates assembler code for that. This here is the expression tree for this expression. And this is the assembler code that we currently have. Now, one optimization would be to use literal pools for loading the address of this left-hand side into a register, but that's a different story. Constant folding is about treating here the right-hand side in a more efficient way, because this right-hand side is obviously a constant value, which could be already computed by the compiler. Currently, we have three instructions for dealing with this right-hand side. We first load this two constants into two different registers, and then we add together these registers. Now, it would of course be better if the compiler would treat this assignment expression as if we would have written this in our source code. Then basically we have a expression tree where we replaced a complete subtree with just one single node, and of course this should be done in general. We should traverse the expression trees, and if we find a node where we already can compute the value at compile time, we should replace the complete subtree with just one node. And from that we then can produce code like that, where we just have one instruction instead of three. Now let's consider an example where this optimization has an even higher impact. In this example, a complete subtree can be replaced with just one node with the value 18, so that 5 instructions will be reduced to just 2 instructions. But here we can do even better, because we have one instruction for subtracting a constant from a register. And if we apply that, then we actually can reduce 5 instructions to just one. And this also works for other operations, of course, for addition, multiplication, and division. If the right child of such an expression node is a constant value, then we should use these instructions where the first operand is an immediate value. If the left child node is a constant, but not the right child node, then in general for a computation we cannot take advantage of these instructions where the first operand is an immediate value, except for example addition and multiplication. In these cases, the operands can be swapped and we still would have the same result. And this is something that we certainly should do in these cases. And then again, we can take advantage of this special instruction and again reduce in this example 5 instructions into just one. That's it already for this video. As I mentioned before, on the website you find more details about how to implement this optimization and also some initial code that you easily can extend for the general case.